Hello and once again, welcome to Physicsify where we are learning about vectors, right? This is part 5 for us and in this case we are seeing the second types of force, right? So let us exactly go and see where we were. We were talking about types of vectors and there were two types that we had already talked about. We talked about equal vectors and we had talked about negative of a vector. The two vectors that we do today are parallel and anti-parallel as well as collinear and coplanar. There are two more left that we would be seeing in the next session, that is concurrent and unit or zero vector, right? Unit and zero or null vector. So let us take up these two for today, that is parallel and anti-parallel as well as collinear and coplanar. So what do we say once we are talking about, let us say, parallel and anti-parallel vectors? As the word says itself, if you put enough focus on this word parallel, you would get the feeling that both of them never intersect, never touch each other. And that is absolutely correct. But what are the things with respect to vectors that we need to know? We should call with respect to magnitude and with respect to a direction. So what we are saying? We are saying that they might have the same magnitude, might not. Magnitude we are not taking care of. The only thing that we would like to see is that we are in the same direction, right? This is more important. Magnitude may be same or maybe not, but this thing is more important, right? So if I talk about parallel vectors, I would say that if let us say these are two vectors a and b, if you are able to see, this is a smaller length and this is a bigger length, this means that b vector has a greater magnitude, a has a less magnitude, because we already know the length of the vector represents its magnitude. So the magnitude might be different, but the direction of both of them is towards east, is what we have learned. Alright. What we'll say in this case is that the angle between the vectors is 0 and that a vector is parallel to b vector. Even if the length of b vector was from here till here, still a would have been parallel to b. In that case, the magnitude was same, it becomes equal to b. So I hope you are getting the difference between equal vector and parallel vector. It's just that the magnitude is a little different. Now we are done with parallel vectors. Let's talk about the second one, and that is anti-parallel vectors. So in this case, as the name suggests, you are going to have the just opposite direction. If you had same direction, in this case, this is the opposite direction case, and what we say is that if we draw a and b something like this, a is pointing towards right, pointing towards east, while b is pointing towards west, and in this case you are saying that these are nothing but anti-parallel vectors. So what do we say? We say that in this case, first of all, the angle turns out to be 180 degrees because they are just opposite. If I have to keep these two vectors, I'd probably keep it like this, a and then b, and then see that this angle is 180 degree. Theta 180 and theta 0 is actually allowed. So this is 180 degree case, parallel is 0 degree case. The next thing that we would like to say here is that they again may or may not have the same magnitude. We are not caring about the magnitude, but the direction is just opposite, right? So we are done with anti-parallel vectors and parallel as well. Let's take up the next part, and the next part comprises of collinear and coplanar vectors. So as the name suggests, like if I would see what is the name that comes to my name, line and co, that means same line. Co and planar, planar comes from the word plane. So I think same plane sort of represents the coplanar vectors. So let us try to see what exactly we have here. We are saying that if we want to tell collinear vectors, we say the vectors which lie on the same line. So if you see, line is the same line is the important thing. And if you want to see an example, you can see an example here. Magnitude irrelevant, so we are not even talking about it, but it should be in the same line. That means these are also parallel vectors, because we know that vectors are free vectors, we can move them anywhere. Talking about the angle, it would be 0 degree like it is in the case of parallel vectors, and If we talk about the next thing now, collinear is done. We talk about coplanar. What we say is that these lie in the same plane. So this word co means same, and co-line means collinear, and similarly coplane means coplanar. That is as simple as it gets. In this case, although there's more to learn with respect to coplanar vectors, because getting it in a line is easy to see, but talking about planes become a little more difficult. It becomes three dimensional, and things in three dimension are always difficult as far as physics is concerned. So there's certain facts for you. You can try proving out it on your own, that two vectors will always be coplanar. There is always a plane that can be made with two vectors. Let us say if we had any two vectors, let us say we had a vector like this, vector like this. The plane right now is the screen itself. Right? So wherever you draw two vectors, they will always be coplanar, but three may or may not be. Right? A third can come out of the plane, can go into the plane, but maybe it is like this in the plane of those two vectors itself, and then in that case this would be the case where three vectors are coplanar. Conditions for these are mostly asked once you talk about mathematics, not with respect to physics. You will get to see it much. So I'll just give you something to ponder about with respect to mathematics, that if you want to prove that whether three vectors are coplanar or not, you say the mathematical way to go about it is to say the scalar triple product is 0. This means it is written in such a way that ABC within brackets, either this equal to 0, or later on we'll learn about the scalar multiplication and the vector multiplication. This is A dot B cross C. This is how we say. B cross C is the vector product, and it would give you a vector. You have to take the dot product with A vector. This is the dot over here, and then if that turns out to be 0, you will say it is coplanar, else not. Right? So anyways, we'll talk about that maybe once we study more maths. That is where we won't like to proceed. Our physics point of view says that we are now done with 4 types of vectors: equal vector, negative of a vector. We're done with the parallel and anti-parallel, as well as collinear and coplanar. I hope that you thoroughly enjoyed this class, and in case you did, I would like to say bye-bye, but before doing that, I'd also like to say that if you find anybody who might be helped from these lectures, do like and share amongst those friends of yours or cousins of yours. And in case you are liking it yourself, why don't you subscribe right now so that you don't miss anything new. We'll meet back in the next session and try to finish off these types of vectors. Thank you.